Hey kids, Math here. We are back with our notes on chapter 15. We're talking about crystals right now. And we left off with water being wet, and now we have crystals. Now, these crystals are solids that we're going to put into water, and they're going to have varying effects. We can have anhydrous crystals. This is how, here are three terms we can use to describe these crystals. The first one is anhydrous. An is a prefix meaning without, and hydrous, without water. These are crystals that what most of us would assume are crystals. Here are three really strong examples of crystals: copper sulfate, sodium chloride, copper or calcium chloride. These three that I highlighted in yellow, those are very normal looking crystals, nothing too unusual there. Well, then we get hydrates, and hydrates are things that I'm highlighting in blue, and they're hydrated in blue because they're crystals that contain water. And this doesn't change the appearance of the crystals. I don't want you getting a mental image that these are dissolved in water. They're not dissolved in water. They just have enough water associated with them that they're like crystals that have humidity. That's a good way of thinking of this, is they're crystals that have water, and they can either give that water off or they can pull that water in. Now, what lets crystals do this is their electron configuration and their intermolecular forces. And they're only going to grab water because, well, that's the relative humidity we have in the air. And so these are solid crystals with water associated with it. Hopefully we can get into lab, do something with this, and show you the difference between hydrates and anhydrous. I believe we did something similar when we studied moles. Now, some crystals contain so much water in them that they have the ability to dissolve themselves. And these are crystals that effloresce. And this, I think, was one of your vocab terms as well, that this is a hydrated crystal that actually has the ability that when the H2O is removed, it dries itself out. So when we raise the vapor pressure, we dry out the crystal. Efflorescent things absorb a little bit of moisture from the atmosphere like that. Okay? Now, along with efflorescent crystals, there are these hygroscopic. And you're not going to differentiate between efflorescent and hygroscopic. Hygroscopic are crystals that absorb water very easily from the atmosphere. Salt does this. If you notice, when you go to the beach and you're at a restaurant eating out oceanside, they always have a little bit of rice in the salt shakers. That rice absorbs the moisture so that the salt doesn't absorb the moisture and get all clumpy, because that salt is hygroscopic. It's ionic. It's grabbing on for things. Now, some things are so hygroscopic that they're deliquescent. Deliquescent are crystals that dissolve each other. Most common one of these we haven't dealt very much with yet is sodium hydroxide. Sodium hydroxide is a crystal, pardon me, it's a crystal that absorbs so much moisture that they can dissolve themselves. So if I took a little piece of sodium hydroxide and put it out on a dish right here in front of me, and I waited throughout this whole video, that solid would just dissolve. And it would dissolve because it would be absorbing all the moisture from our atmosphere. This is a big problem for us in Florida. People in the desert, they don't have as much kind of problems, but we really have to watch some of our crystals, make sure that the lids in the stockroom are put on really tightly. So those are some terms we use to describe. And then we get into these diagrams are an opposite version of how I want to cover them, but these are solutions, colloids, and suspensions. So basically what we have is a solution, and a solution is in this first column, and these are going to be really small solute particles. That's why it's circled here. These are solutions. Don't worry about memorizing the size. Just know if things are very small, they're going to dissolve. And what does that mean? There's no light scattering that goes on. These are very stable, and these particles go straight through filter paper. So if we took salt water and we tried to filter it, nothing would happen. Wouldn't work. These are very homogeneous things. The whole rest of the chapter we're dealing with in 16 are solutions. Okay, now there are large particles, and those are down here, and those are called suspensions. And so for suspensions, think of things like Italian salad dressing. These are very large particles that get just suspended in solution. That's why I have the example of salad dressing up top. These are big. I'm going to talk about the Tyndall effect in a minute. These are unstable. What happens to that Italian dressing as we let it set? Well, it separates out, right? Sure it does. So they're unstable. The particles can be filtered. We could filter out that dressing and get all the chunks and things out. So these are heterogeneous mixtures. Now the one in the middle is the one that's kind of unique. And these are medium particles. And these are called colloids. And colloids, for the best example I have for you guys, is fog. Fog is a colloid. Fog is when you have moisture, water particles, very small water particles that are kind of, they're just hanging, they're suspended. These are medium-sized particles, and they exhibit the Tyndall effect. What's the Tyndall effect? Well, that's where there's light scattering. If you're driving in your car and it's foggy out and you hit the brights, what happens? The light scatters and it looks white. You can't see through fog. Don't ever use your brights when you're driving in the fog, okay? You keep your lights down low. You don't want light hitting a colloid. Colloids scatter light. So do suspensions. We call this the Tyndall effect. I don't think that was one of your vocab terms, but Tyndall effect is when particles scatter light. Okay, now these colloids we have, they're stable, they don't separate, and we can't filter them. They are heterogeneous though. We can pull them apart physically. Here's some examples of colloids that you have dispersed phases and dispersion medium. This is basically like a solute and a solvent. And there are just various different forms that we can look at that these are all colloids. The only thing that makes them different than anything else is that they're medium-shaped particles that we have dissolved this way. That's the only difference. And so that leads us up to where we get to solutions. This was just a way of describing water, how water behaves, how it can have some of its functions, some of the properties of things when you put them in water, that they can be hygroscopic or deliquescent, and those kind of things. And then a brief introduction of colloids. Everything we've talked about has just been definition based. I'm Smath. Next video we're going to talk about solutions, how we make them and what they mean. I hope this helped. I look forward to seeing you guys.